Hello everyone. Firstly, I'll just introduce myself briefly and what the kind of things I normally work on, and then I'll cover the load testing with Gatling. So, I'm a software developer, work in a team that mostly creates HTTP and more recently gRPC services. They're client-facing, they get loads that varies throughout the day, peaking, most of our peak is in the evening when everyone's watching TV. And a key part of that, especially more recently, some of the services we're working on, is ensuring that they can handle load, for obvious reasons, but it's being assessed at a much higher level now as well, so we put much more emphasis on that. We use the Gatling Framework for that, and here I'll be covering the basics of Gatling from a perspective of HTTP and some other uses of it as well. So, what is Gatling? Gatling is a load testing framework for HTTP APIs. It is open source. There is also a paid-for enterprise version with some extra features that I won't be covering here. We use the open source version. It can be run in various ways. It's easy to integrate into a build pipeline. It can be run through Docker, just run as a jar. I think it can also just be run as a binary. It creates HTML reports. These can also be integrated into your build tool, so they're nicer to look at. Also can be shared because it's HTML for anyone that's interested. Gives you some graphs. I'll be showing those later on. I did that in the wrong order. So I'm going to cover how the tests are structured and made. It's fairly simple to get going, and it does have some more advanced features that become more useful the more you use it, and also based on the setup of your application itself. So the basic building blocks are simulations. This is like the test suite. And also the entry point into running the tests. It's a wrapper for everything that Gatling provides, and the key part of that are the scenarios. So scenarios is where you define what will happen and also how you set up the requests it will make. You can have one or many, and they can be chained or run concurrently, depending on what your application setup is. There's users, that Gatling calls them virtual users, because they're obviously not real, they're being generated on the fly. You can define how many of these that you would like, and they are what make the requests. You can configure those, and there's some more details in that as well. And feeders. So a feeder is what allows you to vary each request, so you're not repeating the same one over and over again. Obviously, sometimes it doesn't matter if you repeat the same request, but sometimes it could. So if you have caching or anything like that, it allows you to structure the test so that you can make it as random or as repeatable as you wish. And finally, assertions. And these are the conditions that define whether it was successful or not. You can do this on an overall level for every request that was made in the test, and you can also define it for individual types of requests. So I'm going to go through each of those in a little more detail. So simulations, you only have one, and that is the entry point into the test. You can have more than one in the same project, but only one is one at one time. It's just a trait, and the only thing that you implement is the setup function, which takes population builders, which is the type. It's a population builder is a scenario with user injection profiles. The user injection profiles are how you decide how those virtual users are used in the test. So how many of them you have, how many of them you have at any one time. So you don't have to have everything from the start, you can have patterns. And it's easy to run, it uses the familiar SPDT syntax if you're just running it locally, or on CI. You can do Gatling test to run them all, or Gatling test only with your simulation class name. So the scenario has, the simulation is comprised of scenarios. I'm sure that's useful. The scenario is a description of the specific task that you will be running. Gatling, by default, is mostly a HTTP-based tool, but it does support other things, and there are extensions out there as well. Yeah, without anything else, they're usually HTTP. You can have scenarios chained together to mimic the user journeys. So if a normal setup for you is that a user would call one service, get something back from it, like maybe authentication token or something like that, you can then use that to feed into other requests. You can also just have it repeating random requests to multiple endpoints all at the same time as well, if the ordering doesn't matter. So in its most basic form, it's only a few lines, as people would say. So you name the scenario, this appears in the logs. Obviously, if you have more than one scenario, it's useful. You define how long it runs for. This is very small, just one minute. Realistically, you probably wouldn't want to run a lot longer than that to get an understanding of what happens. And then the Gatling default HTTP. This is where other extensions might provide you different types of request name, whatever you want it to be, and then this is just to get a local host address. That isn't a lot of use by itself, but it shows that it's quite easy to get going, and that would run, though you wouldn't get anything from it because there's no session or users. So once you have the scenario, you need to configure the users. Essentially, you need to define how many you would like, but also you can decide if that user will call all of the chain requests. So if you do have the scenarios chained, the same user will go to one, then the next, like that. So you can use that to mimic real use behavior rather than each request being fairly random. Each user is associated to a session, and the session can store values that either come from a feeder or come from the results of a request. And this is how each user can have state. That state is lost between each scenario. So the users can be reused many times during your simulation, but the session keeps on being reset. So it's as if it's a new user rather than the same user being reused. and you can configure the users the way that the connections from the users are made as well. So you can share the connections. That would probably be more useful if your typical requests might come from a fixed place. So if you're like a back-end service and the customer traffic is coming to you via another service, you might know that you've only got a certain number of connections, so you can have it configured like that, or you can turn off sharing completely and each user will open a new connection to more closely mimic customer-facing requests. So when you've decided how many users you want, you can then start to put them into this scenario. The session that they have can be populated with a feeder. So the feeder allows you to pass in request parameters, any kind of parameter. It's nothing more really than a map. And you can use those as query parameters, headers, JSON bodies, whatever you want, path parameters. You set it up yourself. It's you have complete control over it as long as it's a map. It can pretty much be used. You can make it a val and you can compute out front if you have a limited number of values that you would like to use, or you can have a function that is run repeatedly throughout the test. We've had some issues before with having it as a function for a particular service that takes a big body, in that the test performance has been thought of by Gatling itself. So something to consider is that you're not computing so much that Gatling itself is the limitation. And you can add different strategies to that. You can make there's more types from this, but circular random, so it can just keep repeating in a loop, or it can completely randomize it. The key thing is that if you were just to not set one of these strategies, when the map runs out of data, the test will finish. So by having these predefined strategies, it's quite an easy way just to allow it to never run out. That you don't have to use them if you use an iterator with enough values for the test. You also won't have that problem. It has some easy built-in ones that you can use. If iterators is what we mostly use. You can run it from JSON, CSV files, just any kind of file. So if your endpoint allowed files to be uploaded, then you can have those as well. And then at the end of the test are the assertions. Obviously, at the end, they verify that specific criteria is reached. As I mentioned earlier, you can either have it on a global level or request. For a global level, you might just wish to say 99.9% of requests were successful, or if you have any requirements like that, and you might wish to have different latency assertions on different endpoints if you know that one is very quick and one isn't. So you can mix and match them together. Some examples of the ones that are built in are response time, request per second, error rates. You can also make your own assertions from some of the data it gives you, like number of requests in total, and also percentiles on those. So if you want the 99 to be set at a certain latency, but maybe 90 90th percentile, you might allow a bit more, depends on what you need to do. And then at the end, HTML reports are generated, and as I said, I've got an example of that. There are also checks which aren't assertions, but I put it on this slide because they're quite similar. The check can be used to verify each response. So rather than it running at the end, it checks each response. So you can say if depending on what your application returns, if it's returning an array, you might say I expect there to be at least 10 items in the array, or you can do variable expression matching on it, string matches, so all sorts of things. They will cause the request to count as a failure during the test, but it logs those failures, so you can see that in particular, even though it might be returning a successful 200 response. So you can make sure that the application's actually working, not just very quickly not working. Got a small demo which shows some of those pieces put together, just to show that in a fairly simple form. So you can see it on my screen, but it's not on the screen. So these are the things I was just talking about. Probably if we start from the bottom up, actually. So here's the setup. This is the only thing that's coming from the simulation trait here. Demo scenario, which is above, which I'll show. Here we're setting up the users. In this case, just one, because I'm just going to run it on my laptop. In reality, you might have hundreds or thousands. At once means from the very start there will be one user. You can ramp the users and you can choose how quickly you would like to ramp them. So you could have it going in a soft start curve. We use that because it triggers auto-scaling to happen. And then as it scales up, the number of users is increasing, and it allows us to test that during a peak load period, the application also scales as we would expect it to. Of course, you can also just hammer it from the start with high amounts of users and see how the application responds to something like that, like a very sudden peak. And here is a throttle. I didn't mention that in the slides. This allows you to control how the test is running. So if you were to set this to 1,000 users, Gatling will just make as many requests as it can with the number of users that you've given it, which might not really be what you want. So the throttle allows you to define how many requests a second you would like to handle, which is an easier way to think about it, because you can see how many requests a second you get in production, or is given to you as a requirement, and then you can just put that figure there. It also means that the number of users is less picky, because you can set that to a higher number for the randomness, and not have to spend ages tweaking that figure. And in this case, it's just holding it for 20 seconds, just to make the demo quick. You can have a big mix and match going on here, so you can have a slow ramp period, hold it for a while, ramp up further, or ramp down, or hold it steady. So you can really tweak it to simulate the kind of traffic patterns that you see. and then some examples of the assertions that I was mentioning. So these ones that are global, so they're applied to every type of request. Response time, here is just 150, that's in milliseconds. Successful request greater than 99%, just fairly random figures for example. And then these details allows you to focus on the specific requests. So here they're set the same, but I just did it so you can see the breakdown. Expecting more than 20 requests a second. So, and because it's ramping to 50, that should be achievable, providing the application can support it. This demo the scenario itself. So it's just one scenario. It's just 20 seconds, which matches the throttle period, feeding a feeder, which we'll scroll up to. And then here we see there's two different types of request. I was just making these up earlier. I was going to try and make something that was a bit more related to Scala, but didn't really get to it in the end. So the first request is calling this just user endpoint with some ID. This syntax with the hash curly brackets means it's being populated by the feeder. So we'll see that in a second. There's a check here, so it expects each request response to match the regular expression of just some numbers, and it's saving that that value to the user's session, and I've just called it auth ID. So this is like logging in a user, getting back some token or something. Then calls the next endpoint, just continuing to something else. So now you've got that user's token. It's just all part parameters here. You can have headers or whatever you want. And that auth ID is now in that hash curly brackets because it's now available in the user's session. And this is checking that the response come back just saying success with a number. I just did that really to show the values are being passed around. This is just running while not locally. And the final part is the feeder. So this is the user ID that is used here. As you can see, it's nothing more than a map with a key and value. So the user ID, some random 5-digit string, gets wrapped here in continually, so it will just never run out. This is where you can do. But yeah, you can mix that up and make it random or circular if you have more values in there. You can also give the map multiple keys and use multiple things. It's easy in that terminal, but so there's only one simulation here. This will run for 20 seconds. This is the output that you get in the log. You can see each request and how many successes and unsuccessful ones you've had. And then this is about to finish, and we can look at the actual output. So it gives you a breakdown of response times, the percentile response times, and this is the output, which is nice for when you're debugging something that's failed, because it gives you more information than you see in the terminal. So because this is running locally, we're not doing anything. All of the requests fit into the same buckets. They're all quick. You can change these buckets as well, but through configuration. You see here that all the assertions have passed, and you can scroll down, you can see how things happen. So it will maintain one user for the whole session. If you had a ramp, you would see that ramping, or decreasing, or whatever you were doing with it. See the response times, but then more easily you can see the response times over time. So here it was only between 20 and 40 milliseconds, but in reality, if you had some sudden surge of issues, or if you had a ramp period and at a certain point in the ramp everything started to break or response times started to increase, that helps a lot. Seeing it like this rather than just seeing text in terminal. Just other graphs, they're all quite flat because it wasn't doing anything. So that's the basic example using HTTP, which is basically Gatling out of the box, and using Gatling charts, which gives you the nice output. Something that we use probably more than HTTP now in my team is gRPC. There's an open source library for that, Gatling gRPC. It's basically the same to use. It just gives you a gRPC request builder, and it allows you to check the output of those requests. So just putting it there. It's not open source, but as an example of other ways to extend Gatling to do other things. We have an internal Scala project that we use, which allows you to run performance tests with Kafka, Prometheus, or Fossa. We use that to performance test ingestion from Kafka, and the Prometheus part of that is to allow you to assert using Prometheus metrics, because if you're ingesting things, you can't really make requests to it. So we have that just to use the feeders and allow it to just add a load of items into Kafka or PubSub, and then see the rate at which they're being processed through Prometheus. And that's all for what I have to say. I don't know if anyone has any questions.
Thanks for the presentation. Is that Gatling, can we use it for other languages, like with other languages as well? I mean, the example which you have shown technically work for Scala.
Yeah.
Can we trigger it through Java or some Debian-based language?
I think it does also have a Java DSL. A few years ago, I was in a team that was using Java, and we still just had a Scala project for the Gatling test, because just because at that time I don't think it did have Java. I think it does now. I don't think it has any other languages though. And I think it is still primarily, I think most of the documentation and examples I think are Scala.
Hey Mark. So my question is, how much benefit does having performance tests in your pipeline whenever change? How much benefit does it provide? Does it allow you to catch problems early, where like you see that someone did a change and it's like made performance worse, or is it mostly for reports so that higher management can understand what loads you can handle?
Up until quite recently, it's mostly been used by the developers to catch changes that have affected the performance. Sometimes having it in the pipeline does cause a bit of hassle, because if things aren't set up properly, it fails. But we have caught a couple of bad changes in the past. However, more recently, we've started to have a lot more involvement from managers wanting to test higher amounts of load, or significantly higher amounts of load than what we currently get, based on plans that they have for next year. And so they're running their own tests, so we have to make sure we're prepared for those. And so we've been testing our applications in advance of that. So probably a bit of both. We were using it before we had to, through choice, but now we pretty much do have to. It's also been quite useful for our move to using auto-scaling and tweaking the thresholds of the autoscaler so that it scales up before pods start dying. So we've used it a lot more for that since moving to cloud to the cloud.
Okay.
Hi, thanks for the talk. So I'm wondering about persistence of the test results. So I'm less concerned about how the last build has performed. I'm more concerned about how has the build performed over time, right? And suppose I'm running through Jenkins, and then I've got an HTML report per build I can navigate to. That's fine. But suppose I want to know how has the performance of this build evolved over time, over the last 3 months, 12 months, 4 years. And then another kind of thing to consider is, suppose I want to retain the last 100 Jenkins builds, right? So where can I store these? And then how can I chart them over time if I have some kind of limited retention in Jenkins?
It's quite an interesting point. That's not really something we do actually, but it does sound quite like a good idea. The reports themselves are just those HTML ones, but Gatling itself produces this log file, which is where all the data comes from, and it can be a massive file. It has a line per request, and at the end of the simulation run, it processes that file in order to produce the reports. I suppose there's nothing stopping you from making something that can export that into some other format. I don't know if there's anything like pre-existing for that. It's quite an interesting point.
Actually, the Jenkins Gatling plugin does that. It can keep the history of multiple runs, and you can have like a graph that tracks the performance over time.
Okay.
It's quite neat.
We're not actually currently using the Jenkins plugin, but
That's sort of like for several builds, like depends on your Jenkins credentials, like you won't get data for 4 years.
Any more questions?
Brilliant. Thank you very much. Thank you to Mark for being